Hey again, welcome back. So in the last video of this series we looked at these diffused 5 and 10 mil RGB LEDs. I showed you kind of this method with the potentiometers, how to sort of control each channel individually. Well, today I'd like to take this one here. This is the one with the 150 ohm resistors for the green and blue channel and 390 ohm resistor for the red channel. And I'd love to integrate this, at least in a very crude and simple way, to an Arduino. So let's plug it into the Arduino and I'll show you what I came up with, and then I can explain the code. Here I have just a generic Arduino Uno clone, and I'm going to hook up the 5 volt and ground to the 5 volt and ground of the breadboard. So the black is my ground and the white is my 5 volt. So that means we're going to be powering the Arduino directly from this power supply here. Now we need a way to connect the R, G, and B channels to the Arduino. So you can just stretch the resistors over onto these holes here, but I find it much easier with these pins. So the red channel, which is this 390 ohm here, I believe that goes into 9. The channels do matter, which ones you pick, but we'll get into that later. And I don't remember, I think it's green the next one, so we'll go green here and plug it into 10. And then blue, the last one here, and plug that into 11. So we should have 9, 10, 11. There we go. So again, the Arduino will be powered up using these two wires, and you'll get to see my very basic code. So let's see if I can plug this in, and I'll turn it on. Okay, so there you see it's kind of like a purpley color. Now it's kind of like a greeny color, and now it's like a bluey color. So what this program does, basically, it's written very simply. It's only one page of code. It picks a random value for each, the red, the green, the blue, and it pulses the LED on and off very fast on each channel to a random strength, like a random pulse width, to create the random strength. So that means when these three channels are matched, when the numbers are very close to each other, it'll appear white, but if they're not very close to each other, it could be any number of colors. So this is a very simple code. I'll go through the code line by line to show you what I've done, but it should be said that you can do whatever you want with this code. So this is just the simplest way I could find to integrate Arduino into these RGB LEDs. So let me show you my code. And here is that code in all of its glory. If you can't seem to make out what is written here, like let's say you're just watching this in standard definition instead of HD, you can just go into the link in the description below where you can pick up from GitHub. So first and foremost, I put some comments here. So this code is written by Simple Electronics. That's me. That's my YouTube link. And is free to use, modify, distribute, etc. Yep, do whatever you want with this. I'm a firm believer in open sourcing projects. So yeah, go nuts. Do whatever you want. This is not likely to be amazing code form. I'm not a programmer by trade. Style or formality. Yeah, I could have done things wrong. That's very possible. But it does work, and that's what I was aiming for. Always good. If you watched my rant video, you'll see this is actually revision 2 of this code, but it does now work. So always remember, having fun and learning are the two most important aspects of life. Yep, that's what this channel is all about. So let's get started. So up here is the code that runs. This is like general global variables. So const int red pin equals 9. So that is the pin we're going to use for the red channel. Const int green pin equals 10. That is the pin we're going to use for the green channel. Const int blue pin equals 11. That's the pin we're going to be using for the blue channel. So I think using const int instead of just regular int, integer, is better because I believe the constant takes less memory space. I could be wrong. I am not an expert. But basically you can change these numbers to whatever you want as long as they are PWM pins. So the PWM pins on your Arduino will be different for each microcontroller board, but on mine here, my generic, you'll see that it has a little squiggly beside the PWM enabled pins. You can software PWM the other ones, but it's a lot more complicated, so this is much simpler if you're a beginner. Okay, so these 3 pins, then int wait time. This could have been a constant too, so you can change that if you want. 5,000, that's the delay before the next color swap in milliseconds. Okay, then the int random red, this is a new variable, but this one will change all the time. It will be the strength of the red LED. Same thing with random green, same thing with random blue. So red, green, and blue. We set them to 0 just because I want them at a known state when we start the program. Now we move on to void setup. Now void setup, if you're new to Arduino, it's the portion of the code that runs only once when you first power on the Arduino. So every time you power it on, void setup runs once, and then void loop runs constantly. So we'll just go through one block of code because it's just reset for each channel. But pin mode, red pin, so pin mode of pin 9 is output. Okay, so we want to set it as an output because we want the Arduino to affect the outside world, the LED in our case. So it has to be set as an output. Then I will take a digital write, and I want the red pin to be high. I put this high because my LEDs, my RGB LEDs, have a common power rail. So the power comes in on one pin. If you're not familiar with that, you should check out the link in the description to the previous video. So I put it in a high state to turn it off, basically. So when you start the program, everything should be off. Mind you, this happens so quickly you can't perceive it, but there it is. So then it repeats 2 more times for green and blue. So far, so good. I think this is pretty simple. Next, void loop. This is the portion of the code that will run constantly. Now, this is my interpretation of the Arduino reference material. But so random red, that variable we declared earlier, equals random 256. So it is my understanding that the random function with a number beside it will generate a value between 0 and this number minus 1. So 0 and 255 is what I was aiming for, and that's why I have I have random 256. So now we want to generate that for red, green, and blue. So there we go, these 3 lines of code. Then we want to do an analog write. Now an analog write is done with a pulse width modulation. So picture that a high is a constant 5 volts, a low is a constant 0 volts, and a analog write with a value of 120, whatever 255 is divided by 2, 127 or so. A value of 127 means it'll be pulsating rapidly between high and low. And so that'll give us an average value of 2.5 volts. But you can't just put 2.5 volts on an LED, it probably won't light. So basically it's just going 5 volts, 0 volts, 5 volts, 0 volts, 5 volts, 0 volts. And the amount of on time will depict how bright the LED will be. I'll show you this a little bit later on an oscilloscope so that you have an idea what I'm talking about. So these 3 lines of code here will generate a random value for each of the channels, red, green, and blue. And this here will write that value. So it'll give us a PWM signal, the strength of which determined by these 3 previous variables. So we write the red pin, the green pin, and the blue pin. And then we wait with the wait time, so the delay that we set above, which you can change. And then we do the thing all over again. We'll generate 3 new values, 1 for each channel, and then we will write the 3 values in, and then we will wait. So that's how I got that effect. I think it's pretty simple, and this is perfect for beginners to just download it, put it in your Arduino, read through the comments, try to make some changes and see what happens. Let me try and show you what the channels look like on my little oscilloscope. So I apologize for the extra brightness on this scene because, well, I don't really have a good way to dim my lights, and you need to be able to see the DS0138 in action. So what I have here is I have the positive probe connected to this jumper lead, and I'm just going to probe the red channel, if I can. Okay, and this is what we get. So right now we're getting nothing. That's because I probed beside the red channel. Let's probe the actual red channel. There we go. Now as you can see, down here, flat, would be 0 volts, and up here would be 5 volts. And what you see is every 5 seconds, the duration of the 5 volts and the duration of the 0 volts in total is changing. Right? So here you have more 5 volts than 0 volts. That means because I have common power and 5 volts would turn it off, that means the red is very weak. But if you see something that has much more of this low portion active compared to the high portion, then that means that the red will be more powerful. And you can see this goes again and again every 5 seconds. It just does that forever. I've left this running for I guess about 6 hours once, and it just kept going. It doesn't hang up, doesn't have any issues. So I'm going to move this, and I'm going to probe the blue channel, and you'll see it's the same thing. You see there's a lot more low, and I don't know if you can tell, but the LED is quite blue. Now it's even bluer because look how low it is. Right? So that's why we need a oscilloscope when we're looking at stuff like this, and that's why an oscilloscope is useful, even if it's only this about $15 DS0138 kit that you got to put together yourself. And so that's it, really. I think this is a really nice jumping off point for you to go ahead and try out your own stuff. Download the GitHub file in the link below, and have fun with it, play with it, change some values, see what happens. You can also switch it from high to low at the very beginning if you have common ground, like these 5mm LEDs are. But I think in the next iteration, in the next episode, I will show you how to make this be able to control a large amount of RGB LEDs. In fact, probably a virtually unlimited amount of RGB LEDs, because this one here we are driving directly from the microcontroller pins. So it's relying on the resistance of these resistors to keep the current down to a safe level. I find if I blow up one of these clone Arduino Uno boards, not the end of the world, but I think in the next video I will show you how to properly drive up to like thousands of these, and I think that would be pretty cool. Not much will change with the code, so you can keep the code from this video to move on to the next one, but for sure you should download it, play with it, modify it, share it, have fun with it. As always, thanks for watching.